Earth is in danger. Scientists are a step away from creating a black hole, a scientific experiment that could lead to the apocalypse.
The Large Hadron Collider is one of the wonders of the modern world. It's believed to be the largest and most complex machine mankind has ever created.
Scientists at CERN have just announced a mind-boggling particle anomaly that defies everything we thought we understood about the universe. Observed during high-energy collisions at the Large Hadron Collider,
the experiments at the Large Hadron Collider, itself the largest machine in the world.
This mysterious finding has triggered frantic speculation about hidden dimensions, new subatomic forces, and even the possibility of unraveling spacetime itself. Researchers insist that the transformation could rewrite the foundations of modern physics. Yet the world remains on edge, wondering just how far this discovery's implications may reach. Einstein's theories of relativity and time dilation. Albert Einstein changed our view of the universe with two major theories: special relativity and general relativity. In 1905, special relativity showed that space and time are not fixed. Instead, they depend on how fast you are moving. One of its main ideas is time dilation, which means that a moving clock runs slower compared to one that is not moving. This idea sounds strange, yet it has been tested in many experiments and found to be true. One simple way to picture time dilation is through the light clock thought experiment. Imagine a beam of light bouncing between two mirrors on a spaceship. If you observe this from outside, the ship's movement makes the light travel a longer diagonal path. Because the speed of light stays the same for everyone, the light takes more time to go between mirrors. To the outside viewer, the clock seems to run slower, showing how time can stretch when you move fast. Einstein's second big leap came in 1915 with general relativity. This theory treats gravity not as a simple force, but as a bending of space and time caused by massive objects. The stronger the gravity, the slower time flows. For example, clocks run a bit slower near Earth's surface than they do far above the planet. Though the difference is tiny, it has to be measured for GPS satellites to stay accurate, since they orbit high above us. Another famous example is the twin paradox, which shows how travel at high speed affects aging. If one twin rockets off at near the speed of light, while the other stays on Earth, the traveling twin will return younger. Though it sounds like fantasy, it is grounded in real math and experiments with fast-moving particles.
Twin paradox. What's that all about? That they're the single unmoving person in the universe and everyone is moving around them. And the second thing is that moving clocks tick more slowly than stationary ones.
Particle accelerators, like the Large Hadron Collider, regularly see particles last longer than expected because their rapid movement slows their internal clocks. Time dilation also has practical uses beyond thought experiments. Satellites must adjust their clocks to handle both their high speed and weaker gravity in orbit. If these corrections were ignored, navigation systems would quickly become inaccurate. By merging special relativity's speed-based time effects with general relativity's gravity-based time shifts, Einstein revealed a universe where time can bend and stretch. Though strange, these ideas have been tested and confirmed many times, proving that relativity is more than just theory. It inspires us to keep asking big questions, like how else space and time might change when we push the limits of science. The light clock and time dilation illustration. When Albert Einstein introduced his theory of special relativity in 1905, one of the most intriguing examples he gave was the light clock thought experiment. This simple illustration helps us understand why time can appear to run differently for observers moving at high speeds. The idea is straightforward. Imagine a clock designed so that a beam of light bounces between two mirrors, traveling back and forth. Every time the beam hits one mirror, the clock counts a tick. This design may sound unusual, but it reveals the surprising connection between speed and time. In the thought experiment, the light clock is placed inside a spaceship, moving close to the speed of light. To someone inside the spaceship, the beam of light travels up and down between the mirrors in a straight path. However, to an observer standing still outside the ship, the light beam takes a diagonal path, since it has to move sideways along with the spaceship. This diagonal path is longer than the simple up and down path. Because light travels at a constant speed for all observers, it takes more time for the outside viewer to see the beam complete its trip. This extra time shows up as a slowing of the clock. That difference in measured time is called time dilation.
An illusion caused by the effects of gravity on time due to gravitational time dilation.
The clock does not literally run more slowly from the viewpoint of the passengers inside, but to someone watching from outside, the clock's ticks happen at a slower pace. This is not a minor detail. It has been proven in many real experiments, including those using fast-moving particles. As objects move faster, time for them appears to stretch out when compared to a stationary observer's frame. Scientists have tested time dilation countless times. One famous example involves subatomic particles in accelerators like the Large Hadron Collider. These particles move near the speed of light and would normally decay in fractions of a second. However, because of their high speed, their internal clocks effectively slow down, allowing them to exist longer than expected. This matches Einstein's predictions perfectly, confirming that time dilation is more than just a cool idea. The light clock offers us a clear idea of why time is relative. Although it may seem to challenge basic logic, Einstein's theory is central to modern physics and has real-world uses. GPS satellites, for example, must account for time effects caused by speed and gravity. This simple thought experiment reminds us that everyday events can reveal deep truths about our universe and beyond. The Higgs boson and the Large Hadron Collider, LHC. The Large Hadron Collider, LHC, is a massive machine built by CERN to explore the smallest building blocks of our universe. Completed in 2008 beneath the French-Swiss border, it smashes particles together at high energies.
100 meters beneath the Swiss-French border, and above you is just one of the experiments at the Large Hadron Collider
to recreate conditions that existed just after the Big Bang. By doing so, scientists hope to find new particles and discover hidden forces that shape reality. One of the greatest triumphs of the LHC was the discovery of the Higgs boson in 2012. The Higgs boson, often called the God particle, had been theorized for decades but remained elusive until the LHC provided the energy needed for scientists to create and detect it. This particle is linked to the Higgs field, which gives mass to other fundamental particles, such as electrons and quarks. Without it, atoms, and everything made of them, would not exist in a stable form. Finding the Higgs boson validated the standard model of particle physics, which predicts how particles interact and form the fabric of reality. Yet the standard model cannot fully explain dark matter, dark energy, or gravity, meaning there is still much to learn. Researchers at the LHC continue to push the boundaries, searching for exotic phenomena that might reveal physics beyond the standard model. Experiments within the LHC rely on high-speed collisions. Protons, which are made of even smaller quarks, race through a 27-kilometer circular tunnel at nearly the speed of light. When they collide, detectors record the shower of particles created, offering clues about new forms of matter or unexpected behaviors. This process generates enormous amounts of data that must be carefully analyzed. Thanks to the LHC, scientists can study how often Higgs bosons appear in collisions and how they decay into other particles. This information helps reveal if there might be multiple types of Higgs bosons or if hidden forces are at play. Upgrades planned for the LHC, such as the High Luminosity Project, will increase the collision rate, providing more data than ever before.
Its main objective is to increase the machine's luminosity, that is, the number of collisions in a given amount of time, by a factor of 10 beyond its design value.
By ramping up the LHC's power, researchers hope to uncover answers to profound mysteries. Why our universe contains matter but little antimatter, how black holes behave at quantum scales, and whether hidden particles exist that can explain dark matter. Each new run of the LHC brings fresh clues, inching us closer to a deeper understanding of everything we see, and even what we cannot see. The story of the Higgs boson and the LHC is far from over. More surprises are sure to emerge, promising to reshape our future. General relativity and gravity as spacetime curvature. Albert Einstein's theory of general relativity changed our entire view of gravity. Instead of a simple force that pulls objects together, Einstein explained that gravity arises because massive objects warp the fabric of spacetime. Picture spacetime as a flexible sheet. A star or planet presses down on this sheet, creating a dip. Smaller objects, like planets or moons, roll into these dips, behaving as though a force is pulling them in. This idea replaced the older view that all bodies simply attract each other. In 1915, Einstein proposed that spacetime's shape becomes curved around large masses, causing what we usually call gravitational attraction. One of the first major pieces of evidence for this curved spacetime came in 1919, when astronomers observed how starlight passing near the sun was bent during a solar eclipse. The light's bending matched Einstein's predictions, confirming that mass distorts spacetime. This result shocked many scientists, as Newton's earlier laws had never suggested such a radical reshaping of space and time. General relativity also shows how time can run differently in stronger or weaker gravitational fields. Clocks closer to a massive object like Earth's surface tick slightly more slowly than clocks high above. Today, systems like GPS rely on this understanding. Without correcting for these effects, the timing data needed for accurate navigation would drift, leading to major errors. Although these differences are tiny, they prove Einstein's claim that gravity and time are closely linked. Another prediction of general relativity is the existence of black holes, where space-time curves so deeply that nothing, not even light, can escape.
The general theory of relativity, he was just thinking about gravity and not quantum mechanics. Started to inject quantum mechanics into our understanding of things like black holes.
These extreme regions form when very massive stars collapse at the end of their lives. Astronomers detect black holes by observing the intense energy produced as matter spirals toward the event horizon. More recently, scientists have also detected gravitational waves, which are ripples in spacetime created by dramatic events such as black hole collisions. These waves were first confirmed in 2015, again verifying Einstein's ideas. Despite its success, general relativity remains a focus of research. Some try to modify it or combine it with quantum theory, seeking a deeper theory of everything. Others explore alternatives that might address cosmic mysteries like dark matter. Yet, a century after Einstein's initial publication, no experiment has toppled general relativity's core claim. Gravity emerges from the bending of spacetime. By seeing gravity not as a force but as a shadow of curved geometry, Einstein's theory opened a new window on reality, forever changing how we understand the universe. Conspiracy theories surrounding CERN and the LHC. CERN has always been a magnet for wild speculation, especially regarding the Large Hadron Collider, LHC. This massive underground machine smashes particles together at near light speeds, and that alone has sparked many dramatic theories. Some people claim the LHC could create black holes that might swallow our planet, while others insist it might open funnels into parallel dimensions. Rumors also suggest that these experiments can warp reality, leading to bizarre phenomena like the so-called Mandela effect, where collective memories seem to shift mysteriously. For years, conspiracy theorists have pointed to unusual events at CERN as proof of secret agendas. One dramatic rumor claims that human sacrifices took place within the facility, fueled by a viral video showing hooded figures staging a sinister ritual. CERN quickly labeled it a hoax, yet whispers persist. Others accuse the LHC of ripping holes in our reality, possibly creating time loops or merging parallel universes. According to these stories, the experiments at CERN risk causing irreversible harm on a cosmic scale. In truth, scientists at CERN have openly addressed such fears, explaining that any black holes formed would be microscopic and vanish almost instantly, posing no danger. Modern physics strongly supports the safety of high-energy collisions, and the scientific community widely dismisses the idea of dimension-hopping disasters. Still, the public's fascination lingers. The notion of thousands of brilliant minds digging into the mysteries of the universe just below the Swiss-French border seems almost too good or too threatening to be true. For certain believers, however, it is precisely that grand ambition that invites suspicion. They argue that CERN is messing with forces beyond human control or tampering with spiritual realms. Some link the LHC to ancient symbols found around the site, claiming secret societies direct hidden rituals there. Others see the statue of the Hindu deity Shiva on the grounds as proof of arcane activities. No matter how many times CERN officials dismiss these claims, intrigue continues to swirl around every new upgrade or discovery. Future upgrades and scientific goals of the LHC. Scientists at CERN are always looking for ways to enhance the Large Hadron Collider, LHC, and push particle physics to new frontiers. From the moment the LHC was first built, researchers planned upgrades that would let them explore phenomena beyond the standard model of physics. One major development is the high luminosity upgrade, set to begin around 2029. This project will boost the collision rate within the LHC's massive 27-kilometer ring.
A major upgrade, known as the High Luminosity LHC Project, or HiLumi, is currently ongoing,
providing a rich trove of data for scientists to study. By having more frequent collisions, physicists hope to spot rare events that can reveal new particles or interactions. During this high luminosity phase, the LHC will generate up to 10 times the amount of collisions compared to previous runs. This means scientists can gather huge amounts of information about how subatomic particles form and decay, allowing them to test bold ideas about dark matter, hidden symmetries, and even extra dimensions. The data might also help solve puzzles like why matter won out over antimatter after the Big Bang. By sharpening the detectors and refining analysis techniques, experts anticipate the upgraded LHC to unearth phenomena that challenge current physics theories, paving the way for discoveries that reshape our understanding of the universe. More awaits. In addition to higher collision rates, upgrades include improved detectors that can better track particles and measure their properties with exact precision. Researchers hope to refine measurements of the Higgs boson, the particle discovered in 2012 that helps explain why many particles have mass. If unexpected decay patterns emerge, it might hint at hidden particles linked to dark matter or unknown forces. Scientists also want to explore the possible existence of multiple Higgs bosons, as predicted by theories beyond the standard model. By boosting the LHC's power and data-gathering abilities, these projects may open a window onto realms of physics never before seen. Stay curious. Ahead lies the possibility of a brand new collider, sometimes called the Future Circular Collider, which could dwarf the current LHC and reach even greater energies. However, this ambitious plan comes with significant costs and debate over whether resources should be spent on other scientific pursuits. Still, the main focus right now is on the LHC's next phase. By around 2029, the high luminosity upgrade will be fully operational, setting the stage for groundbreaking results. Researchers hope these findings will shed light on dark matter, the imbalance between matter and antimatter, and more. Many believe these upgrades will uncover fresh clues that could redefine human knowledge forever.
You just mentioned China. I want to follow up there. There are a lot of new EVs there. What does the future of that marketplace look for you?
Tesla's new transport revolution goes beyond EVs, reimagining mobility, work, and even industries. But the question is, why is China shocked by Tesla's new generation of transport? China, the world's largest EV market, has seen many breakthroughs, but Tesla is redefining the game. Buckle up, because the future of transportation is here, and it's unlike anything you've ever seen. How Tesla is revolutionizing the transport industry. This new generation of Tesla vehicles isn't just about being electric. It's about transforming what we expect from a car or a truck. And what's even more shocking is that China, the world's leader in electric vehicles, is stunned by what Tesla has brought to the table. Let's take a look at 4 key innovations that have people talking around the globe. Tesla's Model Q is designed to make electric cars more affordable and accessible for everyone. The Cybertruck is breaking all the rules with a futuristic design that's turning heads. And then there's the Tesla Semi, which is set to completely disrupt the freight industry. Oh, and we can't forget about the Roadster, a car so fast it could change everything we know about speed. These groundbreaking vehicles are not only shaking up the electric vehicle market, but they're also shocking China, a nation that has been dominating the EV space for years. What exactly makes these Tesla vehicles so special? One of the standout features of Tesla's new generation of vehicles is the Model Q, which is set to launch in 2025. This isn't just another car, this is a game changer in the world of affordable electric vehicles. Tesla has always been known for making high-end cars, but with the Model Q, they're aiming for the mass market. This is a car that promises to make electric driving accessible to everyone, no matter their budget.
Cost of autonomous transport will be so low, you can think of it like individualized mass transit. We'll move from supervised full self-driving to unsupervised full self-driving.
The Model Q is set to change the entire game by offering the power and technology of Tesla at a more affordable price. Think of it as Tesla's answer to the mass-market electric car. It's not just affordable in terms of the price tag, but also in terms of efficiency. The Model Q is designed to have long battery life, with a range that can go over 300 miles on a single charge. For the price estimated to be about $30,000, that's incredible. While the Model Q may be an entry-level option, it doesn't compromise on style. The car features Tesla's signature sleek, aerodynamic design, with a clean, modern aesthetic that people have come to expect from the brand. The interior is minimalistic, with the usual high-tech touchscreens and intuitive controls that Tesla is known for. Despite being a more affordable option, the Model Q doesn't sacrifice performance. It delivers a smooth, fast, and responsive driving experience. With Tesla's cutting-edge battery technology, this car accelerates quickly and drives with precision. It has features like the lithium iron phosphate, LFP battery options with 53 kWh and 75 kWh configurations. The electric powertrain allows for instant torque, meaning you won't have to wait for that extra push when you hit the gas. Now let's move on to one of the most anticipated vehicles in Tesla's history, the Cybertruck. When Elon Musk first revealed the Cybertruck, it left everyone speechless.
So I present to you the Cybertruck.
Despite a bold rollout complete with smoke and lights, the Tesla Cybertruck is off to a bumpy start. The electric pickup truck billed as an alternative to traditional pickup models.
This vehicle is unlike anything the world has ever seen before. It's bold, rugged, and defies every expectation we have of a truck. Forget everything you know about truck design, because the Cybertruck is a complete departure. Its angular, stainless steel body looks like something straight out of a sci-fi movie. It's not just a design choice. The stainless steel exoskeleton is built for durability and protection. Unlike traditional vehicles, the Cybertruck's body can withstand intense impacts without showing a scratch. Performance is where the Cybertruck really shines. Tesla has taken its electric technology and turned it into a machine built for tough work. The Cybertruck can haul massive loads, tow up to 14,000 pounds, and accelerate from 0 to 60 miles per hour in just 2.9 seconds. Yes, you heard that right. Less than 3 seconds. This is not your typical truck. This is a high-performance, high-strength vehicle that's perfect for anyone who needs power and versatility. The Cybertruck is built to handle anything. Whether you're in the city or the backcountry, this vehicle will take you wherever you need to go. With its all-terrain tires and adjustable air suspension, the Cybertruck can tackle rough roads and even off-road adventures with ease. It's the perfect blend of utility and innovation. Next up is the Tesla Semi, a vehicle that's set to disrupt the freight industry.
So we were incredibly excited tonight to actually deliver our first production Tesla semi-trucks.
For years, we've seen diesel-powered trucks dominate highways, hauling heavy loads across the country. But that's all about to change with the Tesla Semi. Tesla has taken everything it's learned about electric cars and applied it to a whole new industry: trucking. The Tesla Semi is a battery-powered truck designed for long-distance hauls and big loads. It can go up to 500 miles on a single charge and can haul up to 80,000 pounds, all while operating at a fraction of the cost of a diesel truck. The most surprising thing about the Tesla Semi is the cost savings it offers over traditional diesel trucks. According to Tesla, the Semi will save operators around $200,000 per year in fuel costs alone. Combine that with the fact that it's also easier to maintain, electric vehicles have fewer moving parts, and the Semi becomes an extremely cost-effective option for trucking companies. Last, but definitely not least, is the Tesla Roadster, Tesla's next-generation sports car that promises to take speed and performance to a whole new level. The Roadster is nothing short of a speed demon. It can go from 0 to 60 miles per hour in an incredible 1.9 seconds, making it the fastest production car in the world. Tesla's innovative electric motor technology gives the Roadster the kind of acceleration that you'd typically expect from supercars that cost millions. But speed isn't the only thing that makes the Roadster special. This car is designed for long-distance driving, with a 620-mile range on a single charge. That's unheard of in a sports car, where most models only offer a fraction of that. Whether you're driving on the open highway or on the track, the Roadster is made for performance and endurance. Inside, the Roadster features all the latest Tesla tech, from the massive touchscreen interface to advanced driver assistance systems. It's a car that's not just about speed, it's about comfort, style, and innovation. The Roadster is a peek into the future of high-performance electric vehicles. Why China is shocked by Tesla's new generation of transport. Tesla's new generation of electric vehicles isn't just making waves in the United States or Europe. It's also sending shockwaves through China. China, as the world's largest car market and a major player in the electric vehicle industry, is no stranger to innovation in the automotive world.
China has become the world's largest auto exporter, and it is just starting to ship electric vehicles, causing some concern to the likes of Elon Musk and Tesla and a number of other car makers.
So, what is it about Tesla's latest releases that's causing such a stir? First, let's talk about China's dominance in the electric vehicle market. China has long been seen as the world leader in electric car production. Chinese automakers have been aggressively pushing for electric vehicles, EVs, for years, with companies like BYD and NIO leading the charge. But Tesla, led by Elon Musk, has always been a force to be reckoned with. And now, with its latest innovations, Tesla is stepping up its game in a way that's leaving China's automotive industry stunned. China's electric car manufacturers have been on a winning streak, creating affordable and high-quality EVs that cater to a broad range of consumers. However, Tesla's new models, such as the Model Q and Cybertruck, are changing the game. These cars are not just about electric power. They come packed with cutting-edge technology and offer features that rival anything produced in China. In particular, the Cybertruck is a massive shock to Chinese manufacturers. Why? Because Tesla is introducing a completely new type of vehicle, one that blends futuristic technology, all-terrain capabilities, and unbeatable performance. The design alone is unlike anything else, and it's putting a lot of pressure on Chinese automakers to think outside the box and innovate at a higher level. One of the main reasons China is so shocked is Tesla's battery technology. While China has been pushing its own advancements in battery manufacturing, Tesla's continued breakthroughs in battery efficiency and energy density are making their mark. The Tesla Semi and Roadster, for example, use Tesla's new generation battery cells, which offer higher performance and longer driving ranges compared to most of what China's top EV manufacturers can offer. These longer ranges and faster charging capabilities are critical for both the semi-truck industry and the high-end sports car market, and they're putting Tesla in a unique position of power. Another game-changing aspect of Tesla's new generation is its autonomous driving technology. While China has its own autonomous driving projects, Tesla is at the forefront of self-driving cars. Tesla's full self-driving, FSD technology, is more advanced than most systems available in China, giving Tesla a significant competitive advantage. The Tesla Semi and Cybertruck both benefit from Tesla's autopilot system, which allows for greater efficiency and safety on the road. This technology is already being used in the Tesla Semi for highway driving and could revolutionize the way trucks transport goods across borders. China has been a vital market for Tesla. Musk's company has been steadily increasing its footprint in the country. With its recently completed Gigafactory in Shanghai, they hope to producing more vehicles than ever. With this new wave of electric vehicles, Tesla is looking to increase its share in the Chinese market even further. For China, Tesla's success is both an opportunity and a threat. On one hand, Tesla is providing competition that pushes local companies to innovate and raise their standards. On the other hand, China's government and companies are wary of the influence that Tesla and other Western companies could have on their domestic electric vehicle market. What's even more interesting is that Tesla is adapting its products to meet China's market. For instance, the Model Q is designed to be affordable.
And we'll look forward to catching up with you in our next video. Have a great rest of your day. We'll see you next time. And thanks for watching.